All right, as we start this lesson, what we're going to look at today is, in particular, new ways of factoring. We've done X method, we've done GCF. I'm going to show you two other techniques that we can factor equations. That's the whole goal for today's lesson. Two more techniques. Before I do that, I want to warm you up here. So on your packet, just in the white space on the front page right there, I want you to go ahead and write this out so you can just get in your frame of mind. I don't know when you learned this, maybe third or fourth grade. When you first learned how to divide, and your teacher set this up like this. I know today, you probably just look at that and say, well, the answer is 4. Okay, but when you were first taught to divide, the questions that you would ask yourself is, how many times can 4 go into 1? Can 4 go into 1? Yeah. No, and if it can't, then you add in the next number. How many times can 4 go into 16? You just told me. 4. Answer is 4, and you put the 4 right there. I think that it does this. So I'm gonna take that away. And take this one away. There we go. Let's fix that. Okay, so it goes in 4 times. And so then the next step in the process is the part that a lot of students have forgotten because, frankly, you haven't had to do this in so long, is you take this 4 and you multiply it times the other 4. What is 4 times 4? 16. You put the 16 there. And now, would you add those together and write 32? You would subtract them. Okay, but what does it say to subtract? No, you just know to automatically switch the sign. And so what is 16 minus 16? 0. And when you're first learning division, you don't know anything about decimals yet. So after you've divided all the way across these numbers, we did 16 there, there's no other numbers. You would say this leftover number, you'd call it something that started with an R. The remainder. Does this one have a remainder? No, no remainder. Great. It went in evenly. So the answer would be 4. Okay, let's do this again. Let me erase that arrow there. Let's do this again. This time I'm going to change the numbers. What if I was talking about 5 going into 21? The questions you'd ask, again, get in your third grade frame of mind here. 5 go into 2. Can 5 go into 2? No, so you move on. How many times can 5 go into 21? 4. Again, we got 4. So then you would multiply 5 times 4 and you would get 20. Okay, and this is the part I really want you to write down just so you can remember that this is actually how it happens. You don't add these together. That's a positive 21, that's a positive 20, but you don't add them together. What do you actually do instead? You would subtract. And so we would minus 20, and so we would say 21 minus 20 is 1. That's the remainder. If you have forgotten, you could write the, oh, by the way, what do you call this part right here? What's the name of that piece? The answer to division. Starts with the Q. Quotient. That's it. That's the, it looks like a, oh, let me try that again. Quotient. This is the quotient. Okay. If you remember, oftentimes you might also write your answer this form. You might say the quotient, and then you write the remainder as being divided by the divisor. That right there is the divisor. The thing doing the dividing. Divisor. And so you might say this is 4 1/5. Now I'm going to give you one more. What if we were dividing 3 into negative 17? Let's go third grade here. Can 3 go into negative? Can 3 go into negative 1? Can 3 go into negative 17? Yes, it can. How many times does 3 go into negative 17? Here are 5. But the problem with 5 is 3 times 5 is 15. Keyshawn, you saying?
Negative 5.
Negative 5. Okay, because 3 times negative 5 is negative 15. Now I want to point this out again. This is the part, the reason the whole reason I'm doing this is right here. You don't look at that and say, oh, negative 17, that must be negative 32. What do you actually do instead? Would I subtract 15 like it says right now to do? You would add it instead. And so negative 17 plus 15 is?
Negative 2.
Negative 2. That's the remainder here. Okay, so I just wanted to walk you through on all of these. We switched the sign right there. We switched the sign. Why do I want to point that out? I'm going to call that the fundamental rule of division. Is that we're going to, when you actually go to divide and simplify your numbers, you have to change the signs. So I showed you basic problems because we're going to apply the same math now to complex functions. So today we're going to divide functions. And so the first technique we're going to look at is long division. So in example 1 here, it says to factor this long equation completely using long division if 2x minus 5 is a factor. Okay, I want to add some stuff to your notes. When you get to your homework on Alex, they might call this f of x. The function that's getting divided, function that's getting divided, they might call f of x. The 2x minus 5, that's our divisor. So I'm going to write that as d of x. Alex might call that d of x. Why would they call it a d? Use the letter d. Because that's doing the dividing. That's right. And so what I want you to do is write out 2x minus 5. And then outside the house or whatever you want to call it, the division symbol there. And underneath the house, we'll write in our dividend. That's the actual word, but the equation f of x. So which is 6x cubed plus 17x squared minus 104x plus 60. I want to walk you through the steps of how we do long division. It's the same concept of what we were just working on, except for we got to detail how do we get started. Here's the first thing you're going to do. You're going to divide the leading term of f of x by the leading term of the divisor, which is d of x. So that's going to be our first step. So question for you, as you look up here, what is my leading term of this function in here, this f of x? 6x cubed. Don't write this red arrow yet. I'm just pointing out that's the leading term. And what's the leading term of the divisor? 2x. And so we're going to divide those. Now, a lot of people know exactly how to do this by this stage. A lot of the time you get to pre-cal, but in case you don't, 6x cubed, up at the top of the screen, I'll write, what is 6x cubed actually? 6x cubed is 6 times x times x times x. And we are dividing that by 2x, which is just 2x. So how I write this out is like this. What is 6 divided by 2? 3. Now, some teachers don't put it in this location, but I do. Since I'm dividing this 6 by this 2, I'm going to put the 3 directly above that 6. And now you have these x values here. What happens after you simplify those x's? What are you left with?
2x.
The 2x's. Now, would I write that as 2x or x squared? X squared. I'm going to put that right above the x cubed because that's where that came from. Now I'm going to erase these arrows because I told you you don't need those. So now that brings me to the second step. What do we do from here? Well, if you remember on this little basic thing, I said we multiply these numbers. Here I have a group. So when you multiply a group, it's called distribute or distribution. So I'm going to distribute. So this 3x squared is going to multiply with 2x and also with negative 5. You're correct. Was that Vanessa? 2x times 3x squared. What is 2 times 3? 6. And as we just discovered up here, it should be getting the same thing. We have 1x, 2 more x's. How many total x's is that? 3. That's 3 powers of x. Okay, but we don't just multiply the 2x times the 3x squared. You also multiply negative 5. What's negative 5 times 3x squared? Good. Negative 15x squared. Great. So now this is the step. Some students don't distribute that. There is a percentage that make that error. This is the third step, is the step that most students, if you're going to make a mistake, it's right here. The third step is what I call the fundamental rule of division, which I'm not going to write it that way because that would make no sense for notes. What I'm going to say is we change the signs, and then combine our like terms. So change signs and combine. If you want to write out combine like terms, go for it. But what I'm going to do the rest of the day is change signs plus combine. So here I go. These are the terms of combining, but I'm going to change this sign. Right now it says positive 6x cubed, so I'm going to make this one become negative. And this is a negative right now. So we're going to make that become positive. So I change those signs. And now I'm going to combine my like terms. I'll simplify. So 6x cubed and 6x cubed cancel out. And now 17x squared plus 15x squared is Good. They combine and they give us, I hear 32x squared. Good, Vanessa. Good, Aaron. Good math. Step 4. Here, bring it down. I call it drop. Drop and repeat. Drop plus repeat. So what do I mean by drop? This negative 104x, that's the next term that we have not used. It drops down. So negative 104x. And now I repeat. So back on up to step 1. The leading term of f of x divided by the leading term of d of x. Well, the leading term of f of x has been changed. What is now our leading term of f of x?
32x.
You got it, 32x squared. And it's going to get divided by 2x. Now I'm going to erase this for a moment because I don't need that arrow anymore. So up at the top, 32x squared, this is a reminder, means x times x. And that's getting divided by 2x. So the x's simplify. What is 32 divided by 2? 16. And since I'm writing it in line with this column, I'm going to put it right here. So it makes a complete column. 16x to the first power. There's only one x left over up there, so it'll be 16x. So that's step 1. I took my leading term and divided by my leading term. Okay, step 2. I now distribute. So I'm taking this 16x and I'm multiplying it by 2x and also by negative 5. What is 2x times this 16x? What is 2 times 16? 32. And this x times this x gives us x squared, x to the power of 2. Very good. Now we also, because we're multiplying, I need to distribute. So what is negative 5 times 16? Oh, some mental math champions in here. Negative 80, I agree. And how many powers of x? Just 1. That takes us to step 3. We're going to change our signs and combine like terms. Negative 32x squared, I agree. Good, Mason? Plus 80. You got it. So these simplify out of there. And now negative 104x plus 80x. Negative 24, great. Negative 24x. And now, since I combine my like terms, it's all that's left over. I get to step 4. It says drop and repeat. This will be the last time to drop and repeat, because 60 is the last value I can possibly drop. So here we go, one last time. Let me erase my previous step 2, the distribution. All right, let's start all over. One more time. It says to take the leading term of f of x divided by the leading term of dx. What is my leading term of f of x now? Negative 24x, and it's going to get divided by 2x. Shouldn't have shifted down yet. We can go back up to the top one last time. Negative 24x divided by 2x. The x's simplify. What's negative 24 divided by 2, Natalia? Negative 12, I agree. So again, I'm writing it in this column. That's how I do. So if you go search YouTubes for other teachers, they might group them by columns, but I think it's easier just to do it the way we've been doing since 3rd grade. So I try to just do things the same way. Honestly, it doesn't matter where you put it. Now I distribute. Step 3, or excuse me, step 2. What is 2x times this negative 12? Negative 24x. Great. And what is the negative 5 times negative 12? Positive 60. All right. Step 3, the last step for us. Change signs and combine like terms. So this again is what I call the fundamental rule of division. If you hear me say that, it's to change the signs. This becomes a positive 24. This becomes a minus 60. I can simplify these terms. And I simplify these terms. What's left over then? 0. That means that our remainder, r of x is what I'll call it, for a remainder, is 0. This tells us 2 very important things. If your remainder is 0, this tells you what you divided by. In this case, 2x minus 5. 2x minus 5 is a factor. is a factor of this equation f of x since the remainder equals 0. If your remainder is 0, it's a factor. And as you learned last class, if something is a factor, that means it's also a 0 when you solve for the x. So let's solve for the x here. If I wanted to solve for x, I would say 2x minus 5 equals 0. What would be your first step? Plus 5. Great. This is why we typically say inside lies. The inside with x's, because when you solve them, everything goes opposite. So instead of it being a minus 5, now it's 2x equals positive 5. And then what's our last step from here? Divide by 2. So when we divide by 2, we found a 0. X equals 5 divided by 2 is a 0. Does anybody know what that is as a decimal?
2.5.
Yeah, because we're going to look at a graph in a second, so you know that value is a 0, an x-intercept. That's an x-intercept. All right, so this technique that we just did right here is called long division. Any idea why we call that long division?
It's forever.
It was long, pretty self-explanatory. Sorry. So that is long division for you. I do have I'll call it a cheating technique, although it's not technically cheating, that I'll show you in a moment, but I want to walk you through. It was a 4-step process that was repeated multiple times. And the very important thing is right here at the bottom. When we got that 0 is a remainder, it told us 2 things. What are the 2 things it told us? That the original thing we were dividing by is a factor. And secondly, that factor will generate a 0 for us. Okay, now back up to the problem. It says factor this equation completely. Here's what that means. To continue factoring until you found all of them. Well, there are still more factors out there. What I need to do is look at the quotient. I didn't even label this right up here. This value, this quotient, I'm now going to rename this here, this quotient, I'll call it Q of x. The quotient, Q of x here, has 2 more factors. I know that because there's a second power of x. So there's 2 more factors in there. I don't have to use long division though now. This is now a trinomial. What technique have we learned to factor trinomials? X method. So off to the side over here, I'm now going to do X method on the quotient. So step 1, what was step 1 when you do X method? GCF. So I'm going to take the GCF of our quotient. Does our quotient have a GCF? Can 3 go into 3, 16, and negative 12? No, which one does 3 miss on? 16. Can't go in there. There's none. So the first day of school, we said n/a, or there's none. It's not applicable. There's no GCF. Okay, the second step for X method is where you actually do the X process. I'll just call it the X method here. I'm going to draw an X. At the top of X, I put the A times C value. At the bottom of the X, I'm going to put the B value. So let's label these A, B, and C. Okay, thank you. So what is 3 times negative 12?
36.
Negative 36. And our B value is 16. And if you remember how the rest of the way what we did the first day is I labeled these M and N. It doesn't matter what letters you use, but ultimately we're looking for 2 numbers that'll multiply to be 36, but either combine to be 16 or have a difference of 16. And we'll figure out the negatives in a little bit. So if you need a technique, you can write out a T-chart. What are different factors of 36 you can think of? I hear 36 and 1. I agree with 36 and 1. I heard that. I heard 6 and 6.
18 and 2.
18 and 2. Okay. I heard 4 and 9. 12 and 3. That's all of them. You got them all now. All right. Looking over this list, which one could either add to be 16 or if you subtract could be 16? 18 and 2. Those are going to be our numbers. Which one is it, adding or subtracting? Subtracting. What are we subtracting? 2. So it's going to be 18 minus 2. All right. What was step 3 in this process? Split the A terms power. Split. And I started just saying split A. But since it's been a long time for the notes here, I'm going to say split A terms power. Split A terms power. So what I do is I come up over here, and I'm going to take the A term that's right here and split its power. So its power is a 2. When you split the power 2, what are you left with? Just power 1. So it'd be a 3x in one parenthesis and a 3x in the other parenthesis. So I split the A terms power, and I include the two numbers from our x method. So the plus 18 and the minus 2. We have one step left. What was our last step? Simplify. Good. Step 4 was to simplify. And you have to do this anytime your A is greater than 1. Our A is 3 here. We have to simplify. Which factor gets simplified? The front parenthesis, the back parenthesis, or both parentheses? Just the front. What goes into both numbers? 3. 3 is all that goes in. So when we simplify it, we find the last two factors are x plus 6. That's the front factor here. And 3x minus 2. So we've now found all the factors. Those are factors there. 2x minus 5 was another factor. So here's our factored form. The original equation I called f of x, so I'm going to call it f of x again here. F of x could be written as the factor 2x minus 5 times the factor x plus 6 times the factor 3x minus 2. That's factored form. So we have just completely factored it. And now, just to be extra, what zeros would exist? There'd be 3 zeros here. We already found this one. This one we said was x equals 5 divided by 2. We added 5, we divided by 2. What zero would be generated if we solve this factor? -6, that one's easy. And what about this one? Y'all are good at this. You would add the 2, so it'd be a positive 2. And then how do you get rid of a 3 that's multiplying? Divide by it. Okay, so writing all this out, you might be wondering, why did he write all this out? He didn't ask for zeros, because this leads us into a huge shortcut. If you understand that factors and zeros work together. Hey, medium. Medium. So let me show you the graph. Whoops. Here we go. Here's the graph of this equation. I've graphed it here. How many zeros do you see in this on the picture of the graph? 3. So what I'm doing here is I'm pausing the algebra, and I'm going to show you a way to quote unquote cheat, which means how could we have done this without going through all this work? If you look at the graph first, it has 3 zeros. Their locations are -6, 0.667, and 2.5. Those are our zeros. Well, what you would do first is make sure that all the values, if they're not a whole number, you would get them as a fraction. So what I'm going to do is type in these zeros. Now, if I type in 0.667, which is this 0 right there, a fraction button pops up. If I press it, it'll say it's 667 divided by 1,000. Well, I'll tell you, that'll never be your numbers you're working with. This 0.667, the Desmos has rounded. Does anybody have any idea what that decimal should be if it's unrounded? 2/3. And it's just going to be a bunch of 6s repeated. So what I'm going to do here is to take away the 7, and I'm just going to type in a bunch of 6s until here. You see how it automatically went to 2/3? That's the fraction I'm going to work with. Now, if you're paying attention, that's this value right there. -6 is already shown to us right there. And now let's do 2.5. 2.5, you hit the fraction, it says it is 5/2. Okay, so if you were only using the calculator, how could you do all this work that I've just shown you right here? Here's how you could do it. Let me get a new page. You would graph, and you would find the zeros. So here's the calculator cheating way, is graph and locate zeros. Graph plus locate zeros. When I did so, we got the zeros -6, 2/3, and 5 divided by 2. Cool? Step 2, separate the zeros individually. So just find some space to write this down. I'm sorry, you might be limited, but I'm gonna write this as x equals -6, x equals 2/3, and x equals 5/2. Step 3. Turn zeros into factors. But no fractions. It's very important you got this. No fractions. So that'll change how we solve. So let me talk about how we turn this 0 into a factor. You take x equals -6. To turn it into a factor means you set everything on one side and get this back to where it's equal to 0. So what is the opposite of subtracting 6? You would add 6. And so I would have x plus 6, and you just put it in parentheses, x plus 6. There's one factor. You don't set it equal to 0 with any factor. You just leave it like that. I do it over here. I do this again. Now here's the deal. I say no fractions, which means I don't do the opposite of 2/3. Opposite of 2/3 is -2/3. I don't do that. I have to get rid of the fraction. So if I want to get rid of the fraction, what is the opposite of dividing? Multiply. So I multiply both sides by 3. This gives us 3x equals 2. I'm almost done. What's the opposite of 2? -2. So I subtract 2 from both ends. Will this become 1x? 3x minus 2, does that become 1x? No, it's just, they're not like terms, so you just keep them separate. This is the factor 3x minus 2. Okay, now I'm going to do this one. This 0. The 0 is 5/2. Again, no fractions, so I got to get rid of the fraction. What is the opposite of dividing by 2? We multiply both sides by 2. So 2x equals 5. Now, to finish this as a factor, I got to get it equal to 0. What is the opposite of 5? I subtract 5 from both ends. So I'm left with 2x minus 5. Okay, whether you realize or not, what I was just doing is I just came up from the graph. From this graph, all I did is I typed it into the graph. I located the zeros. I graphed and located the zeros. I turned those zeros into a fraction, though. I separated the zeros individually, and then I turned them back into factors without leaving anything as a fraction. What did this do for me, these 3 factors? What it did is this entire page of work right here, which it is some work, but this entire page is what we did here. Now, which one was less work? This page or this page? We'll call it page 1 or page 2.
Page 2.
Page 2 was a lot less work because this one, half of it was just me writing. And we got the same answer that's written right there just by using graphing technique. Okay, so here's what I want you to do. Your first DOL, I want you to try, not the algebra yet. I'm going to do another one of algebra because I think you need to see 2 algebras before you do a long division. I do want to see if you can do the long division shortcut that I was just showing you. Whenever you're just factoring, I want you to graph and see if from the graph you can come up with the correct factors from here. DOL number 1.